Welcome back to Organic Chemistry. I hope you had a great weekend and now you're full of energy to start a new week. So in this lecture, we're going to go after alkanes and cycloalkanes. Okay, first we need to know what's the meaning of, alkane or cycloalkane. Okay, we're going to start with hydrocarbon. And what's a hydrocarbon? A compound that is made of hydrogen and carbon. It depends the number of bonds between carbons. It can be saturated or unsaturated. If the bond between carbon and carbon is a single bond, or technically you have just a sigma bond between them, one sigma bond, and in that case we're going to call it saturated. But if you have sigma, and then let's say you do have a pi bond, whether one or two pi bonds. And so anytime you get a pi bond, the compound will be unsaturated. Okay, so unsaturated. For example, for the second molecule, I have two pi bonds. The second and the third one, and there are pi bonds. So I'm going to say that molecule again is unsaturated. If you have a ring, and that ring, in order to reach octet, and happen to have pi bonds, we're going to call it unsaturated. Again, it doesn't matter how many pi bonds you have. If you do have a pi bond, the compound will be unsaturated. Okay, the question is, how do we name them? The first thing that we need to know, okay, what's the longest chain? Because we're going to use that one as a parent, and we're going to say everything that attached to it, we're going to treat it as a parent. Then we will be looking anything that attached to it. And we will ask ourselves, what are they and where are they? Okay, so we need to know who's sitting or attached actually to the main stem or main tree, and what are those branches? Okay, name them. Next, where are they? And so, for example, in this case, I have a molecule. Okay, clearly it has a bunch of branches, but I need to pick the longest chain. The longest chain, and it looks, this is going to be the longest chain. Okay, why that's the longest chain? If you start, for example, you start from here, you get 1, 2, 3, 4, 5, 6, 7, 8, 9 carbon. So we have 9 carbons. And that's the reason I call it the longest chain. Can I have a different chain? Let's give it a try. Okay, so for example, we said okay, we can have this one, or we can get that one. We can start from, forgive me, can start this and then go here, or maybe we can go that way. Okay, and so this is 1, 2, 3, 4, 5, 6, 7, 8, 9 carbon, and the rest I go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, and this is going to be 1, 2, 3, 4, 5, 6, 7, 8. So as you see, the longest chain is going to be number one. Number one, it has the longest chain, and the rest, rest or inside rest of those structures, we have either 7 or 8 carbon. So I'm gonna pick number one as the correct answer. Okay. Now, what will happen if you are dealing with same number of carbons? Let's say the parent happened to have the same number of carbons. So okay. But one of them, it has a different number of, branches or substituent. Which one of this is going to be the correct answer? The one I'm talking about, it, if you start, for example, from here, you start from here, this is going to be your longest chain. And also you can go here. That's going to be the longest chain. Okay. And try to label number of carbons. I go 1, 2, 3, 4, 5, 6, 7. And how about here? 1, 2, 3, 4, 5, 6, 7. So I have 7 carbons in both cases. Okay, which one of them is going to be the correct parent chain? it will be the one with more substituent. And what do I mean by substituent? Stuff that they are attached to the main chain, okay, to the purple or red one. And so I have one substituent for now. Let's call this one an ethyl, or we can call here, we call this one substituent, two substituent, and this is going to be the third substituent. Well, here we have one substituent, and that's going to be the second substituent. So the one with more substituent, it will be the correct answer. If you are dealing with two chains that they have exactly same number of carbons, the only difference between them, one of them has more substituent than the second one. The one with more substituent, it will be the correct parent chain. Okay, the correct parent chain. So the correct parent chain, it will be this one. Next. Okay, so we're going to be talking about alkane. Okay, so let's write this one. So we will be dealing with alkane. Okay, and the formula for alkane, it will be this: CnH2n plus 2. Okay, 2n plus 2. So you're going to use this only for hydrogen. Okay, let's give it a try. If n is equal to 1, that means we have only one carbon. So I'm going to say C1. How about H? It will be 2 multiply 1 plus 2. And that's going to give you C1H4. Okay, I don't need to write the 1, so I'm going to say CH4. Okay. If this one is 2, it will be C2H. 2 multiply 2 plus 2, and you will get C2H6. So the first one was like a C1H4. I said there is no need to write one, but if you write it, that's fine. Okay, and if you increase this one, for example, to 3 or say 4, you will get C3, and H, it will be 2 multiply 3 plus 2, and that's going to give you C3H8. Next, I go C4H, 2 multiply 4 plus 2, and that's going to give me C4H10. Okay, let's highlight a couple of things. First, every time we add 1 unit to carbon, okay, every time we add 1 carbon or 1 unit to carbon, number of hydrogen atoms will go up again by 2. Okay, let's double check it. So we started with 1 carbon. How many hydrogens we have? 4 of them. Okay, 4 of them. Now we decrease carbon to 2. What will happen with number of hydrogen? It will be 4 plus 2. Okay, I'm going to increase this one to 3. What will happen to a hydrogen? It will be 6 plus 2. Again, I increase this one to 1 more. It will be 4, and hydrogen, it will be 8 plus 2, and it will be 10. Okay, so always you will have 2 more hydrogens attached to the new molecule. Okay, so let me highlight it that way. Cool. Next, let's go after one of this molecule, and for example, CH4. This compound is completely saturated. It has 4 sigma bonds. Okay, and what's the hybridization for carbon? It will be sp3. How about electron geometry? It will be tetrahedral. Okay, and how about the molecular geometry? Because you don't have a lone pair, again, it will be tetrahedral. Okay, how about the bond angle? Okay, the bond angle, any bond angle you pick, theta, it will be 109.5 degree. Okay, next, I wanna teach you how to present a tetrahedral geometry, or how to draw it. So you will draw carbon inside the plane. Next, you will attach 2 hydrogen to it, and those 2 hydrogen, they will be inside the plane. So we have hydrogen, attached to carbon, hydrogen attached to carbon, and those they are in the plane. Okay, in the plane. Which plane? Same plane that you have carbon, hydrogen, and hydrogen atom. Okay, next. One of the hydrogen will be pointing to you. Okay, this hydrogen, it will be pointing to you. So I'm going to say I have a hydrogen. This one is out or is pointing to us. And next hydrogen, it will be back of the molecule. And this is the way we're going to show it. Okay, so this hydrogen is back. And so this is the right way to present geometry of tetrahedral carbon. Okay, so please practice this one. Why? Because in organic chemistry, we do care a lot about geometry of the molecule. We want to know whether that substituent or that atom is pointing to us or far from us. Why? Because it's going to change the chemical reaction or maybe product that you get them at the end. Okay, next one. What will happen if you change one of this carbon, okay, one of this hydrogen by a carbon atom? Okay, so let's take, for example, this. Okay, I'm going to say, how about this? We have CH, we have C2H6. So this time we have two carbons. Okay, we have one carbon attached to another carbon. Now we have a carbon-carbon bond, and each carbon will be attached to 3 hydrogens atom. Three hydrogen atom. Cool. Next, I want to present this. How about going after one of this sites? Let's go after one of this carbon. Okay, so I'm going to say the carbon that I'm highlighting, it will be this. Forgive me. This is the carbon that I'm highlighting. Next, erase one of this hydrogen and replace it by carbon. So, for example, this carbon, this hydrogen is gone. Now I'm going to have CH3 there. Okay, CH3. Can I change, position of the CH3 with another hydrogen? Yes, you can do it. You can, you can put the hydrogen, the CH3 anywhere. It doesn't matter. All the position are identical in this case. And both carbons, both of them, they will have sp3 hybridization. Okay, that means in both cases, electron geometry, which is equal to the molecular geometry, will be equal to tetrahedral. Okay, and what does it mean? It means this. It means any bond angle you pick. For example, you pick this bond angle. This bond angle is 109.5 degree. How about the bond angle between CH3 carbon and another hydrogen? I'm talking about, let's say, this. That one also 109.5 degree. So any bond angle that you pick, anyone that you pick, it will be 109.5 degree. Why? Because we don't have a pi bond. This molecule is saturated. Okay. Now, it depends how many carbons are attached to that carbon you have. We have a way to name them. Okay. If you have a carbon, so this is the carbon that I'm studying. Okay. If you have a carbon that attached to 3 hydrogens and only one carbon attached to it, I'm going to call it primary. This is going to be a primary. Okay, we write 1 and we say, okay, we put the degree on the top. So there is only one methyl group attached to it. And this is, sorry, when I say methyl, I mean only one carbon is attached to it. Okay. What if you have 2 carbons? So I'm replacing one of the hydrogen now by a methyl, by CH3. Okay, CH3. And in this case, I'm going to say we are dealing with a secondary carbon. So we say 2 and we put degree there. Okay, if you replace, okay, 3 of the hydrogens by CH3, in that case, here, you're going to get such a geometry. And this is the hydrogen that we are studying. Forgot to highlight it for the previous molecule. Okay, so now our carbon, the yellow carbon, is attached to three neighbor carbons. Because it is attached to three, we're going to say this is tertiary. Okay, but if you have four carbons, then you say 4 and you put 0 degree on the top of it. That means you're dealing with a quaternary. Okay, so let's pause here. In the next lecture, I will be talking about alkane versus alkyl. And I will see you very soon. Thank you very much.